So logistics on your test, obviously it's Monday. You don't have a calculator for any of it. It is all open-ended. It is 16 questions. Yeah, I think it's 16 questions. And it involves all the stuff we've covered from Unit 4. So Unit 4, Section 1, Unit 4, Section 6, A, B, C, Unit 4, Section 7, and Unit 4, Section 10. So 1 was parametrics. It's been a little while since you did this because this was before the break, right? So there's 3 different types of parametric questions. 1 where you're graphing using a t-chart. So like you could get something like x equals t plus 2, y equals t squared. Okay, and it will ask you to graph it. I'm literally going to give you the t-chart. I'm going to give you the range so that this is like easy for me to grade. So let's say it says like it's between -2 and +2, and then I'm going to give you the t-chart. So remember, you get a t, you get an x, you get a y, and then you get an x, comma y. So you simply plug those values in. So it'd be -2, -1, 0, 1, and 2. And then you just plug them in. So I plug in for x equals -2 plus 2, which is 0. X equals -1 plus 2, which is 1. X equals 0 plus 2, which is 2. X equals 1 plus 2, which is 3. And x equals 2 plus 2, which is 4. Then I repeat the process, God bless you, for y. So y equals t squared. -2 squared would be 4, -1 squared would be 1, 0 squared would be 0, 1 squared, and 2 squared. And then you're going to write out the coordinate points. So it's 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. And then I'll give you the graph, but it will ask you to graph it. So 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. And connect them. And then don't forget your arrows. So the arrows point towards the largest T, okay? Questions on graphing the perimeter. Try to make it as foolproof as possible, like by giving you the range and all that stuff, so that shouldn't be too bad. Okay, then came eliminating the parameter. So let's say we use the same 2 equations. Let's say I get x equals t plus 2 and y equals t squared. The goal with eliminating is to get rid of the t, right? So we solve one of these for t and plug it into the other one. And you get to choose. So I would say, obviously, I would avoid the square root if possible. So if I do the top one, t would equal x minus 2. And then I plug that into the bottom, and y equals x minus 2 squared. You do not need to expand and FOIL if, like, there's not going to be any combining of, like, terms after that. But I would say, like, if it said, like, +1 here, and so there was a 1 out here, and you could actually expand and combine, like, terms, then I would like to see you do that. But if that is all it is, if it is just x minus 2 squared, then you're done. This would be the answer to expanding the parameter, and this was not here. Questions on that one? Okay, and then the last one, which was the one that has like somewhat confusing directions, it'll say find the parametric given the equations, and you will be given one that has a t and one that doesn't. So you get given one parametric and one rectangular. So let's say it says x equals t plus 2. Okay. So then x equals t plus 2 could be the parametric one, and then you'll get something like y equals x plus 3, let's just say. So whichever one does not have the parametric, or whichever one does not have the t, you need to introduce the t into it. So I take the one that does have the t, which in this case would be x. If it wasn't solved for x, I'd solve it for x. This one already is. And then I would take what x equals and plug it into the other one. And I get y equals t plus 2 plus 3. And y equals t plus 5. And the answer to this question will be 2 equations. The first one, solve for x, so x equals t plus 2. and the second one solve for y, so y equals t plus 5. So there is one of each of those types. Yep.
For the graphing, you said the arrow points where?
It points to the biggest t. So like if you go in order, if you actually do your t chart in order from least to greatest, then it points to the last one you plot, which is what I would recommend to do. People like to do things different just to be different. But I would recommend going in order of the t from smallest to largest, and then you just point to the last one.
What did you do with y equals t plus 2 plus 3?
So one of these equations is going to have a t, and the other one won't. The one that has the t, whatever variable is with it, you solve for. So in that case, it was x. If it wasn't solved, like let's say it said x plus 2 equals t. Well, it would have said x minus 2, but let's say it said it that way. Then the first thing I would do is isolate the x. So it would be x equals t plus 2. Then take that and plug it into the other equation in place of the x. So you're bringing the t into the one that doesn't have a t.
Oh, okay.
Questions on any of those? Again, that's parametric, one of each. Okay, then came all your conics. We started with the circles and the parabolas. So it's gonna, first of all, we'll go through all the equations and then we'll talk about the different kinds of questions you can get. But the standard form of a circle is x minus h squared plus y minus k squared equals r squared, where hk is your center, r is your radius. For each of the conics, you need to know how to get information about that conic, give me the equation, or get an equation that's not in standard form and put it into standard form by completing the square. And also, if I gave you the equation, you'd have to be able to pull the information out of it and graph it. So for each of the conics, like you're going to graph a circle, you're going to graph a parabola, you're going to graph an ellipse, you're going to graph a hyperbola, but you're also going to have to give the equation, so you have to go both ways in this with this information. So with a circle, obviously I could give you the equation, ask you to complete the square, find the center and the radius. And then when you go to like, what happens if I give you the information, you could either be given a point and the center. So I could give you an XY and I could give you the HK. And for those, you would just literally plug those four in to the equation and then solve for R and then plug back in the HK and the R. Or you could get given the endpoints of a diameter. So in the homework and the notes, there were point and center. And on the review is endpoints of the diameter. Be prepared for either. If you had to do the endpoints of the diameter, so I'd get like x1, y1, x2, y2, then what you don't have is the center. How do you find the center if you have the endpoints of the diameter? Good. So you're going to do the midpoint to get the center. And then I would use that and one of the points and plug it back into your equation, find your R, and then find your equation. So that's how the circle could get given information about the circle. Obviously, I could give you the center and the radius, but it's not going to be that easy. All right, then comes questions on the circles. Obviously, you know how to graph them too, like find your center, count up, down, right, left, your radius. Then came the parabola. So you've got ones that are horizontal, meaning they point right or left. And for these, your equations are the y squareds. So y minus k squared equals 4px minus h. A positive 4p points to the right, a negative 4p points to the left. A vertical parabola points up or down. And for these, it's x minus h squared equals 4py minus k. And positive 4p points up, negative 4p points down. Remember, there can be nothing on the front of the squared term. So if there was something there, you'd need to move it to the other side. And if there was something attached to the variable, you would have to factor it out. So if I had something like x minus 1 squared equals 4p minus 6, not 4p, sorry, 4y minus 16, I would have to take the 4 and factor it out. You cannot leave it attached to the y. And again, there can be nothing on the other side. If there was something on the other side, I'd move it. There can't be anything in front of the squared term at all. And then there can't be anything attached to the one that's raised to the first power. You have to take it out of the parentheses. Unless there was nothing, like it could be just 4y, but it can't be anything with a constant afterwards. And then for both of these, the HK is your vertex. The P is the distance from the vertex to the focus, and the distance from the vertex to the directrix. Remember, the focus is a coordinate point, and the directrix is either an x equals or a y equals. I would say that's a common mistake people make with the directrix. Make sure it's not a coordinate point. Thank you. So just like with the circle, I could give you the equation. You might have to put it in standard form by completing the square. You're going to do that at least twice on the test. So complete the square is going to happen out of 2 of the 4 conics. Then, or I could give you the equation already in standard form, and you just have to pull out of it the vertex, the directrix, and the focus, and then also you'll have to graph it.
Wait, what does that say?
Which one? Next to directrix?
The white.
All right, then came ellipses. So 2 different types of ellipses, horizontal, where it is wider than it is tall. These are your ovals. And for that, the a squared is under the x. So it's x minus h squared over a squared plus y minus k squared over b squared equals 1. Vertical, taller than it is wide. Order does not matter. So I could put the y first. The most important thing is the a is now under the y. And how do you know what a is in an ellipse? Good. A squared is larger.
And for horizontal, your a values are on the x-axis.
Correct.
And then for vertical, your a-axes are, your a's are on the y-axis.
Correct. So your A is the distance from center to vertices. B, distance from center to co-vertices. And C, distance from center to foci. Your c squared equals a squared minus b squared. Remember, it's the opposite sign of your standard form. Also, for both of these, 2a is your major axis and 2b is your minor axis. So again, like a parabola, and a circle, I could give you the equation. You might have to put it in a standard form, or you get given the equation already in standard form. You'd have to be able to find the center, the vertices, the co-vertices, the foci, okay? And it's going to ask for eccentricity, which is your C over your A. And remember, the closer it is to 1, the more rounded it is. Closer it is to 0, it's flatter. Not that that matters, really. It just confirms your graph. All right, then came hyperbolas. Hyperbolas, you also had horizontal and vertical. Hyperbola, horizontal ones were the ones where the branches point right or left. And this was an x minus h squared over a squared minus y minus k squared over b squared equals 1. And vertical, it opened up and down, or pointed up and down. And that's a y minus k squared over a squared minus x minus h squared over b squared equals 1. And this time order is important, right? Because a is what? Good.
And the same thing applies for like the A. So the A is on the y-axis for vertical.
Correct.
Okay.
Yep. The obviously first major change was the minus in between the equation from ellipse. Second major change is A is first. The vocab terminology changes for major and minor, right? So like 2A is called a transverse axis. And 2B is called your conjugate axis. So that would show up like if I gave you information about the hyperbola and you had to find the equation, I could say the transverse axis is 16 and that means your B is 8. That's how you would see that show up. I'm going to come back and add the asymptotes in there under that, but A, B, and C are exactly the same. Center, 2 vertices, center, 2 covertices, center, 2 foci. A and B, A and C are on the, I think we said it on the last one, but we didn't write it out. A and C are on the transverse axis, and B is on the conjugate axis. And the other major difference is that C squared equals A squared plus B squared with a hyperbola. So you need to be able to find vertices, covertices, foci, asymptotes, and eccentricity is still C over A. If you have a horizontal hyperbola, then your asymptote is y equals k plus and minus b over a x minus h. And if it's a vertical, it's y equals k plus and minus a over b x minus h. And this time your eccentricity will be bigger than 1. The bigger the number, the wider the branch. 4-7 was vectors. So I really cut back on a lot of that stuff. I basically carried over the component form, the magnitude, adding, subtracting, or using the scalar, the dot product, and then graphing. So no unit vector, no vector in the direction, no angle between. If you want to look back on that stuff, I cut that stuff out. So the component form, let's say I have my initial point, that's x1, y1, and my terminal point, that's x2, y2. Then to find the component form, I do x2 minus x1, comma, y2 minus y1. And remember, order here is important. Unlike with slope, where it would kind of work itself out with its sign, component form won't, because you're keeping them separate. Then if it asks you for magnitude, and you have initial and terminal, one choice is using the distance formula, right? So you could do that. If you don't have the initial and the terminal, then you have to use square root of a squared plus b squared, but it's also kind of a shortcut if you already have the component form. So I would do square root of a squared plus b squared. Okay, again, or distance if given initial and terminal. If you're not, if you're only given the component form, then you have to use square root of a squared plus b squared.
The distance formula is
The square root of x2 minus x1 squared plus y2 minus y1 squared. So you could always use that to check too, if you have the time and you want to go back, you could check that answer.
I was thinking of that
like, so from here, whatever this answer is, let's say I get like 4, -5, then I can use, I would say square root of 4 squared plus -5 squared to get the magnitude. All right, then we added, subtracted, and had scalar multiples here. Like if I gave you u was 4, -5, v was 1, -2. Could you add them together? Could you find a scalar? That kind of stuff. All those things are based on that, okay? This is not like the matrices where you have to worry about like the dimensions because it's only a scalar and a scalar, right? You can only do it that way. And the dot product. So if it is the dot product, this would be 2 already in component form. So this would be like u1 comma u2 and v1 comma v2. It's already in component form, like it already has the brackets. And for dot product, we do u1 times v1 plus, don't forget to add it together at the end, u2 times v2. So this is a single number. So let's say I said u was, let me give the one that's up here. What did I say? 4, -5? Yeah. 4, -5. And v was 1, 2. Then my dot product would be 4 times 1 plus -5 times 2. 4 minus 10, which is -6. So dot product ends in a single number. Now you'll see there's a couple practice on your PDF where it combines these two, right? Like it might say like find 4u dot v, or like u times 3v, whatever it is. You can, if it's a scalar like a 4u, I would multiply that scalar in on that vector, and then, God bless you, and then I would find the dot product at the end. Questions on those? All right, then came graphing. So this is the one where you have to like make your like weird parallelogram shapes, right? Like, so if I said find 3u plus 2v, you're gonna triple the length of u. You're gonna double the length of v going in the same direction. And then we draw out, because we're not gonna have notability, so we're not gonna be perfect, okay? And it's okay, but you're gonna extend out the ends of those vectors parallel to the other side. Where they cross is the end point, and then, wow, that's fun. Connect them. And how would it change if I said 3u minus 2v? What's that minus do? Switches the direction. So I would still use 3u as it is here. Like I would still use this one. But then my 2v, I'm going to go in the other direction, the length of 2 of those segments. And then I would draw my lines out of those two, plot where they finish, and that would be that one. Yep.
Do you have anything in like the other form? Like
IJ.
Yeah.
So like it could be given to you in IJ, like these coordinate points could be given to you in IJ. Like it could say, instead of saying 4 -5, it could say 4i minus 5j, like that. You would need to know that's a vector. Yeah. I think on the PDF there's some of each.
Okay.
Yeah. If not, I'll add one on there, but I think there is. Yeah. Mm-hmm. Yep. Okay, so then matrices, I feel like is especially the easiest one. We just finished it too. We did it like we did it last year. Here's my only warning about matrices. Like, don't try to do things in your head and make a stupid mistake. Like, take your time with these, right? Go slow to go fast. Like, take your time with these. Make sure you're careful, because it would suck to get a question wrong because you didn't put a negative, or you try to do a minus. Everybody like tries to do the minus the negatives in their heads, and for some reason y'all are just so smart, but those negatives tend to bite you in the butt. So I would say just be really, really careful. Like, take the time to write stuff out. So there could be adding, there could be subtracting, there could be scalar multiple. So I could give you a equals whatever and b equals whatever, and it could say find a plus b. It could say find 7a minus 2b, right? Like, any of those things are fair game. Make sure you can do it first instead of wasting the time of actually starting to do the scalar and then finding out you couldn't do it to begin with. In order to add and subtract, remember they have to be the same dimensions. So you can only add a 2x4 to a 2x4. You can only add a 2x3 to a 2x3 or subtract. And then the multiplying, remember we go across and down. So for multiplying the row and column of the first one, the middle two numbers have to match in order for it to be done. And then the outer two is the result. So if it's a 2x3 and a 2x3, we cannot multiply because the middle two do not match, okay? But a 2x3 and a 3x2 works. The middle two match. The outer two would tell you it's a 2x2. And then you work your way across and down.
And do we put impossible if it's like?
Yeah, you could put cannot be done, impossible, whatever. That's fine. Yeah. Questions? Also, don't get cocky on those. Like, at least practice them. There are someone that I think there's 2 on the review. You definitely need to do them. So I'm gonna let you work on the review, and then tomorrow I'll leave a couple. Like, it won't be the full thing. I'm just gonna leave a couple problems from here to like, because one, I don't know where you're gonna be tomorrow. I don't know if you're gonna be in the gym. Because remember, I'm hoping to go and grab Ash if my cough goes away. If not, I will be home. And you're like, if they throw you in, with the rest of the people in the Lions Den. I don't know what your Wi-Fi access is going to be like. What do you think you want the most practice on? Because I'm not going to do all of it. Is it the conics? Yeah. Okay. Is it